Cool. There we are. All right, I got a series of questions for you, which we're going to ask you really, really quickly. First, we started our discussion of electricity by talking about atoms. Atoms are the smallest piece of matter that you can have. Everything in the universe is made up of atoms. And we talked about 3 parts. Everybody list for me all 3 parts of an atom. What are all 3 parts of an atom? Can you list them all? Chris Todd, go for it. Nucleus. Oh, that's actually a really cool place to start. I wasn't planning on that as an answer. Yes, in an atom there's a nucleus, and the nucleus has a couple parts in it, and then there's a 3rd part rotating around the outside. I need to know what the 3 different particles are. But yes, there's a nucleus. Yes, there are 2 in the nucleus and 1 out. Do you know what one of the particles are? One of the pieces? Oh yeah.
One of them things that we talked about it yesterday.
Yeah, we talked about it yesterday.
The thing that spins around it and then it like take them off of you.
Yeah, that's what we're talking about. Do you remember what they're called? You already dropped. Oh, there you go. Perfect. Yeah, we got a nucleus with electrons going around the outside. Electrons. And then electrons. Perfect. We got 2 others. The 2 that are in the nucleus, hanging out on the inside. What are the 2 others? Protons, one of them, and then what's another, Mari? Neutrons. So we got protons, neutrons hanging out in the nucleus. Good word. I wasn't even looking for that one. That's helpful to us. Okay, we got the nucleus hanging out here, electrons whizzing around the outside, and then he started talking about electrons transfer and all that kind of great stuff. Cool. Let me up it one then and say, does anybody know the charges of those particles? Because of the 3 particles, you have protons, neutrons, and electrons. 2 of them are charged. 1 of them has no charge. Do you know what all those charges are? Shane, Mike, go for it.
Like the electron are negative and
Do you want to stop there? I'll go to somebody else for the other
no,
ones.
protons are negative.
Okay, electrons are negative. Yes, that's a good start. We got 2 other
Protons
pieces.
are positive. I read that wrong.
Okay. No, so electrons are negative, protons are positive,
And the neutrons are neutral.
and the neutrons are neutral. Excellent. That's something that you need to know for Friday's quiz. If you know that, you're in great shape. All right, let me ask a super tough question then. Why don't you go ahead and ask what you want to ask or say what you want to say?
I was watching The Big Bang Theory, and Sheldon was telling a joke, and he was like, so a neutron went into a bar and he got a drink, and the guy was like, he said, how much is it? And he said, for you, no charge.
Ah,
Isn't
that's so
I
hilarious.
didn't get it.
Yeah, if you ever watch that show, to nerdy people like me, it's extra funny because especially this class, do you watch that show?
Yeah.
Do you notice they say a lot of things that relate to what we're talking about in class? That if you watch that show while you take this course, this show is kind of dumb. It has some funny parts and stuff. Some kids like it. I think parts. You'll get a lot of the jokes now that you're taking this class because we actually reference a lot of things in there. That's a pretty good joke. I might write that one. Actually steal a line and say it's mine. All right, perfect. I have a difficult question for you, though. We got protons, neutrons, electrons. Protons and neutrons hanging out in the middle. Electrons whizzing around the outside. We talked about the fact that solid objects are made of trillions upon trillions of atoms. So here I've got a whole bunch of those atoms hanging out. It appears like a solid object to us, but it's actually mainly empty space. Can anybody explain why that is the case? How can a seemingly solid object actually be mainly empty space? That's the hardest question I could probably ask you, so I'm throwing it at you. We'll let Emily take it. What do you think, Emily?
Because the neutrons, they're moving fast around. Like blurry.
Yeah, it's like blurry. It makes up the table. I like that. Anybody want to say it differently? Perfect. That's a great. There's no weakness in that answer. What?
Like they're so small, and they're moving so fast that you can't tell that it just looks out.
Oh, because you're relatively far away from. Oh, like when we were talking about the TV yesterday with the pixels on the TV. You back up, looks like a solid thing, but you get close to it, it looks like. I'm sorry. You back up, it looks solid, but when you get close, you can see the little dots. Yeah, that's a great. Combine those two, and that's like awesome. Something to add, Chris?
Like how they're so small, but there's even smaller spaces in between them because they're like really close together, but there's still some empty places where they're not.
Yeah, there's a lot of empty spaces there, isn't there?
Yeah.
Yeah, it's cool. Here's what, let me throw some big highbrow kind of words at you, see if you understand them. A lot of people look at atoms. In fact, I might as well back this one up. You're the only class that's going to get this, which is kind of cool. It's the only class I told this to, but you seem to have a good understanding. A lot of people, when they draw atoms, like a lot of chemists and molecular people and stuff like that, will actually draw atoms as the big thing, like this. and they call it like a space fill model. Does that make any sense to you, that word, of how they could possibly call that a space fill model? You see what I mean? Sometimes they'll call this an orbital cloud because the electrons are moving so fast, it's like it fills that area, even though technically it doesn't. But if those electrons are moving at the speed of light, they almost might as well be, like the fan blade. Oh, here, turn on the fan, stick your finger in it, but just don't stick it where the blades are. Does it matter? Are the blades really anywhere in that circle at any point in time? Yeah. Touch anywhere in the blurry circle, ding, you're probably going to get it. Could you possibly do this? Sure. But it kind of acts like they're everywhere all the time. And that's kind of how an atom behaves. Great stuff. I absolutely love it. Cool. Let's get into our next little topic here that we're going to be talking about. We're going to be talking about some electrical fields. We're going to make some electrical fields on our table. We're also going to make a huge negative electrical field on one of you today, and some weird stuff is going to happen to you. So everybody remember how I made the balloon that was here negative? Remember we had an awkward moment there where I had the balloon hanging on the string. How did I make that negative? How did I give that a negative charge? Remember? What do we do with that? Yeah. Cool, so then it became negative because I gave it my electrons. And I lost electrons, so I became positive. I have more protons in my body than I had electrons. Why can't you run like protons onto something? Why are we always talking about the electrons? I can go back to this picture if you like. Maybe this picture will help you. Why are we always talking about a transfer of electrons and not talking about a transfer of protons or neutrons? That's a tough one. What are you thinking?
Because the nucleus can't jump from place to place.
Yeah, nucleus is kind of locked down, you know what I mean? You bust that open, you are releasing like a holy heck of energy, okay? You are talking about like nuclear reactions and stuff like that. You can't mess with that. It's floating there, it's moving, but you can't mess with those neutrons. You can't rip them apart or like stick stuff back together. The electrons though, they're easy. You can like rub those off and add more and flow electrons through something. But those protons, neutrons are kind of there to stay. Looks like you have some stuff you want to say to me, so we're ahead of schedule. I'll take them. Shane, what are you thinking, buddy?
You're like super duper slow, like super duper fast. Could I like put my hand to this table and like when it breaks it just goes through that?
Yeah, that's an interesting question. Now your hand's too big. Okay, do you see what I'm saying? Because the atoms are too small. But is that possible? Could you fire something really fast through your table and not have it touch anything? The answer is yes. So what's really small and really fast? I'll tell you. X-rays are really small and really fast. Does that almost kind of make sense to you?
Yeah.
Because X-rays are really small, really fast. They go right through your body. They go right through. Now, where the material in your body is more dense, they stop. But where it's not so dense, like your skin and muscle, they'll go right through. That's how you can take a picture of yourself with an X-ray, which I know sounds weird. You send a whole bunch of little tiny waves that can actually fit between the atoms and molecules of your body. You fire those at you, they go right through. Now your skin, they go right through really, really, look at it like this, look at it like a shadow. Pretend that was sending out X-rays, and I stood here like this. X-rays are smaller than light. They fit in between the atoms and molecules of your body, and they leave a shadow behind. When you step like this, it's going to leave a shadow at the inside of your body. Where the stuff is not dense, it gets through. But where it is dense, it's blocked. That's what an X-ray is. It's like a shadow picture, not messed up, of your body, because you're able to sneak in between the space in between the atoms. And your bones are more dense, so they tend to stop stuff. Man, what a great question. All right, well, let's continue. Since you seem to have a good handle on this, let's bring it up to the next level, and let's start making some of these electrical fields actually at our table. What I need you to do is take a nice blank page. We'll call it journal entry E8. Journal entry E8, and it's going to be about static electricity. Static electricity is a charge that builds up like crazy but doesn't move.